Stop. Volkswagen just signed a deal worth $131 million that proves the silver crisis I've been warning you about is real. On July 23, 2025, VW's battery company PowerCo agreed to pay QuantumScape an additional $131 million over the next 2 years. But buried in that announcement is a number that should terrify every automaker on Earth: 85 gigawatt hours of production capacity. When you calculate how much silver that requires, the math becomes impossible. Let me show you exactly why. Subscribe right now, because what I'm about to reveal connects everything I've said about Toyota, Samsung, and the battery silver war. Volkswagen just joined the fight. And when you see the production numbers they're targeting, you'll understand why there literally isn't enough silver on this planet to power what's coming. Let's dive in. Here's what happened. In July 2024, Volkswagen's battery subsidiary PowerCo signed their first deal with QuantumScape, a California-based solid-state battery company. That original agreement allowed PowerCo to manufacture up to 40 gigawatt hours per year using QuantumScape's technology, with an option to expand to 80 gigawatt hours. 40 to 80 gigawatt hours is enough to equip approximately 1 million electric vehicles per year with next-generation solid-state batteries. That first deal included a $130 million prepayment in royalties from PowerCo to QuantumScape. But then, in July 2025, they expanded the agreement. PowerCo committed another $131 million over the next 2 years upon achieving certain manufacturing milestones. And, critically, they added the right to produce an additional 5 gigawatt hours of QSE5-based battery cells annually. That brings the total potential production capacity to 85 gigawatt hours per year. 85 gigawatt hours. Remember that number, because I'm about to show you why it's impossible. Let me explain what QuantumScape's QSE5 battery actually is. The QSE5 is their first commercial product, featuring a 5 amp-hour capacity and an energy density of over 844 watt-hours per liter. That's significantly higher than current lithium-ion batteries. The charging time is 12.2 minutes from 10% to 80% state of charge. QuantumScape produced the first B samples of the QSE5 in October 2024, and they're now working with PowerCo to scale up production at their pilot line in San Jose, California. QuantumScape's technology platform is based on a proprietary solid-state ceramic separator that enables the use of a pure lithium metal anode. This is transformative battery chemistry designed for exceptional energy density, fast charging, and a robust safety profile. The key innovation is that solid-state separator, which replaces the liquid electrolyte used in traditional lithium-ion batteries. But here's what nobody's talking about: that lithium metal anode requires silver for optimal electrical conductivity in the current collectors and connectors. Without silver, you can't achieve the performance specifications QuantumScape is promising. Now let's do the math. If PowerCo produces 85 gigawatt hours of batteries annually, and we conservatively estimate that each kilowatt hour of solid-state battery production requires approximately 100 grams of silver for anode's current collectors and internal connections, that's 8,500 kilograms of silver. Convert that to metric tons, and you get 8.5 tons of silver per year, just for PowerCo's QuantumScape production. But wait, that's actually a very conservative estimate. Some battery chemistries and manufacturing processes require significantly more silver depending on the specific design. The real number could be 2 to 3 times higher. But let's stick with the conservative estimate of 8.5 tons annually. Now add that to the calculations from my previous videos. Toyota, targeting solid-state batteries, needs approximately 6,000 tons of silver annually if they reach their production targets. Samsung's battery division needs approximately 14,000 tons annually at full-scale production. Now add Volkswagen's 8.5 tons through PowerCo. We're at 20,808.5 tons of silver demand just from 3 companies' solid-state battery programs. Here's where the math breaks down completely. According to the U.S. Geological Survey, world silver mine production in 2024 decreased to an estimated 25,000 tons, compared with 25,500 tons in 2023. 25,000 tons. Now that's total global production from all mines worldwide. Toyota, Samsung, and Volkswagen alone would consume over 83% of global silver production. 83% for just 3 companies' battery programs. But we're not done, because those aren't the only companies developing solid-state batteries. Let me list just a few more. Nissan announced they're targeting solid-state production by 2028. Honda has solid-state programs. Mercedes is already testing solid-state batteries from Factorial Energy with a 621-mile range. General Motors is working with Solid Power. Ford has solid-state research programs. Stellantis signed an agreement with Factorial Energy targeting 2026. Hyundai is launching their Dream battery pilot line in March 2025. BMW's Gen 6 battery gets 620-mile range. The list goes on. And we haven't even mentioned what silver is used for outside of batteries. In 2024, total silver demand reached 1.16 billion ounces according to the World Silver Survey 2025. That's approximately 36,100 tons when you convert ounces to metric tons. The demand categories include physical investment, electrical and electronics, coins and metals, photovoltaics for solar panels, jewelry and silverware, brazing and solder, and other industrial applications. Industrial demand alone reached record levels in 2024, particularly in electronics and electrical applications. Solar panels are consuming massive amounts of silver. The photovoltaic sector used approximately 12% of total silver demand in 2024, and that percentage is growing as solar deployment accelerates globally. Electronics manufacturing needs silver because of its unmatched electrical conductivity. 5G infrastructure requires silver. AI data centers need silver for their server components and cooling systems. Medical devices use silver for antimicrobial properties. Every smartphone contains approximately 200 to 300 milligrams of silver. Your laptop has 750 milligrams. Your flat-screen TV has 1 to 2 grams. The supply side cannot grow fast enough to meet this exploding demand. Silver mine production has been essentially flat for several years. According to the Silver Institute, global silver mine production rose by just 0.9% in 2024 to 819.7 million ounces, which is approximately 25,500 tons. That tiny growth came primarily from increased output from lead and zinc mines in Australia, and the recovery of supply from Mexico as Newmont's Peñasquito mine returned to full production after operational issues. But here's the critical constraint. Most silver, approximately 70%, is produced as a byproduct of mining other metals like lead, zinc, copper, and gold. Only about 30% comes from primary silver mines. That means silver production is largely determined by the economics of those other metals. When copper prices are low, copper mines slow down, and silver production falls as a side effect. You can't just decide to mine more silver. The price of silver going up does not immediately translate to more production because the mining operations are driven by the primary metal being extracted. Mine development takes 7 to 10 years from discovery to production. Even if mining companies started today developing new silver mines specifically to meet battery demand, those mines wouldn't be producing significant quantities until the mid-2030s. But PowerCo's pilot line with QuantumScape is ramping up right now in 2025. Volkswagen is targeting integration of this technology into a vehicle series soon. Toyota and Samsung are targeting 2027 launches. The timeline for demand explosion is much shorter than the timeline for supply response. Recycling helps, but it's not enough. Silver recycling increased 6% in 2024, reaching a 12-year high of 193.9 million ounces, which is approximately 6,000 tons. Industrial scrap saw the most significant increase, mainly from processing spent ethylene oxide catalysts. Higher silver prices encouraged more recycling in Western markets, but 6,000 tons of recycled silver against 36,000 tons of total demand leaves a massive gap that must be filled by mining or by drawing down above ground stocks. So where does this leave Volkswagen and PowerCo? They've committed over $260 million to QuantumScape between the original $130 million royalty prepayment and the new $131 million project funding. They're building a large, jointly staffed scale-up team composed of experts from both companies to accelerate industrialization of the technology. They're developing production processes at QuantumScape's pilot line in San Jose and planning technology transfer to PowerCo's factories. PowerCo is currently building 3 cell factories with a total volume of up to 200 gigawatt hours per year in Salzgitter, Germany, Valencia, Spain, and St. Thomas, Canada. 200 gigawatt hours per year is PowerCo's total planned capacity across all their factories. The 85 gigawatt hours licensed from QuantumScape represents a massive portion of that total capacity. If PowerCo dedicates even half of their total production to QuantumScape's solid-state technology, they'll need enormous amounts of silver, and they're competing for that silver against Toyota, Samsung, and every other automaker racing toward solid-state batteries. Here's what I think happens next. First, we're going to see automakers start aggressively securing long-term silver supply contracts with mining companies. Volkswagen Group is one of the world's largest automakers with deep financial resources. They understand supply chain security. They will move to lock in silver supplies before their competitors can. Second, we'll see production delays and timeline slippages. Companies will announce technological breakthroughs and mass production targets, but when they can't secure enough silver at reasonable prices, those timelines will quietly get pushed back. Third, silver prices will spike. When industrial buyers who must have silver start competing for limited supplies, prices won't just gradually increase. They'll jump sharply as buyers panic about securing materials. And fourth, this will create winners and losers in the EV race. The automakers who secured their silver supply chains early will be able to launch next-generation batteries on schedule. The automakers who waited will be stuck with inferior battery technology or massive cost overruns. That competitive advantage could reshape the entire automotive industry. Toyota has partnerships. Samsung has vertical integration. Volkswagen has capital and scale. But they're all competing for the same limited resource. Make sure you're subscribed to this channel because I'm tracking this story closely. Drop a comment and tell me what you think. Does Volkswagen's $131 million bet pay off? Can they secure enough silver? Which automaker wins the solid-state battery race? I read every comment. And if you haven't watched my Toyota and Samsung videos yet, go check them out. They're the first parts of this story, and you need all the pieces to understand what's coming. Thanks for watching, and I'll see you in the next one.